And good morning, mathematicians, and happy daylight savings. Hopefully you guys remember to turn your clocks forward this weekend. We lose an hour of sleep, which is sad, but we'll get used to it, so hang in there. Alright, so in this video I'm going to go over your unit test review for our test tomorrow. Yeah, so pages 98 and 99 in your guided notebook. Alright, well with that, let's get started. So question number one, this goes back to our lesson of parallel lines and transversals. So things like vertical angles and corresponding angles, same side interior angles, alternate interior, all of those vocab words we went over, those are going to help you the most. My main issue with this is that some students will want to use a protractor, but I encourage you to not use a protractor because this image is not drawn to scale and you will get angles that are incorrect. So do not use a protractor here. I know it's tempting, but don't, unless you want wrong answers. Okay, well with that, let's get started. So my first inclination is to start out with either vertical or corresponding angles because those are the easiest for me to spot out and notice, and we know that those angles are congruent to one another. So I'm looking at 63. Looks like angle E is corresponding, so that's going to be 63 degrees. Okay, angle C is a vertical angle to E, so therefore C is also congruent. It's also 63 degrees. Okay. Let's see what else. I see this 98 degrees. Angle L right there. That's going to also be 98 degrees. H is a vertical angle to L, so therefore angle H is also 98 degrees. Okay. And we have a 111 degree angle here. Looks like angle P is corresponding. So that's going to be 111 degrees. And then M is a vertical angle to angle P. Where's angle M? There we go. This is also 111 degrees. Okay, if you guys are wondering, what does this M less than sign mean? This is supposed to... It's supposed to look a little bit more like this, like it's supposed to be an angle symbol, but the computer only put in a less than sign. But anyway, what this M stands for is the measure. So what is the number of degrees? How big is that angle? So what is the measure of angle A, B, C, and so on and so forth? Okay. All right. The other types of angles that we know of are linear, right? Or not angle, but linear pairs that create a straight angle, right? So for example, I have PN, right? Those two angles are supplementary to one another, so therefore they add up to 180 degrees. So if I subtract 180 and P, for example, let's go ahead and do some quick math here. So I know that angle N is 69 degrees. Okay, now what's nice about this, now that I have this, I actually have angle K. Angle K is corresponding to angle N, so angle K is also 69 degrees. Okay, now let's try another one. Another linear pair that I see is 98 degrees and F. So again, let's subtract from 180 because those angles are supplementary. Do some quick math here. 17 minus 9, well that's going to be 82. So angle F is going to be 82 degrees. 82 degrees. Do I have any corresponding angles? Yes, technically this angle right here. Here, let me do another color because it's starting to get filled with pink circles here. So I'll do red. Where this red circle is, that's corresponding to angle F. And we said angle F is, I lost my place, angle F is 82 degrees. But notice that angle G is a vertical angle to that red circle, so therefore I know that angle G is also 82 degrees. There we go. We're almost done. We only have 3 more. I'm going to switch to another color here. Okay. Let's find angle B. I have a linear pair here between 63 degrees and angle B. So I'm going to subtract 63 degrees from 180. So that's 7, that's 1, and that's 1. So angle B is 117 degrees. Because angle A is a vertical angle to angle B, we know that angle A is also 117 degrees. Look at that. Also, angle D is corresponding to angle B, or it's an alternate interior angle to angle A, and therefore angle D is congruent to A and B. So it's also 117 degrees. Now, the last angle here, angle Q. Okay, here we have to use some of our prior knowledge of triangles here. We know that the angles of a triangle, or the interior angles of a triangle, add up to 180 degrees. So we know that this red circle here, that angle is 82 degrees. Okay, I'm going to switch colors. I need to find this purple angle there, right? But hey, look, I have a linear pair between the angle that I want and this 111 degree angle. So let's go ahead and subtract 111 from 180. I'm going to do some borrowing here. 9, 6. So this purple angle right here is actually 69 degrees. Actually, I didn't need to do that. I could have looked at angle K and noticed that it was a vertical angle to angle K, and therefore it's congruent. So that would have worked too. All right, so I have an 82 degree angle, I have a 69 degree angle. Now let's figure out what angle Q is. First, let's add 82 and 69. It's going to be 11, 14, 15. So I'm at 151. How much do I have left over? 180 minus 51. That's 29 degrees. So angle Q is 29 degrees. And there we go. We found all of those angles not using a protractor. All right, let's keep going. Number 2, write a similarity ratio. This problem here, guys, I want you to find this scale factor. The reason why I'm telling you this is because how we find the scale factor is actually we write the similarity ratio. Okay. So use what you know about the scale factor, use what you know about how to find the scale factor, and that's going to help you get this similarity ratio. Okay. Really, all you need to do is make sure that your corresponding sides are lined up with one another. Okay. And there are 2 similarity ratios you could write. So the first one I'm going to do is I'm going to treat my small rectangle here, MNOP, as my preimage, and RSTU as my image. Okay, and remember with our scale factor, the ratio we write is image over preimage. So I'm just going to go ahead and write 10 over 6, and I'm going to simplify that because I should always simplify my ratios. I can fit a 2 inside both of those, so I have something like this, 5 over 3. And that is our scale factor. That is a similarity ratio. Okay. Let's go ahead and I'm going to write another similarity ratio, but this time treating my rectangle RSTU, see in orange now, RSTU as my preimage, and then MNOP as my image. And you would do the same thing. I'm going to use the other side though. I'm going to use 15 and I'm going to use 9. Okay. So the scale factor we know is image over preimage. Okay. And in this case, my image length is 9 and my preimage length is 15. Let's simplify that. 3 goes into both of those. That's 3 over 5. Okay, and I'll accept either of those. Okay, just make sure you know which is your preimage, which is your image. Is your dilation going to be an enlargement or a reduction? Okay, just don't get the two confused. But I'll take either of those answers. All right, number 3. Here we're using properties of similar triangles to help us find heights of things that we do not know. The way this is labeled is a little misleading. This word right here, this tree, it's supposed to be a title. So this is the triangle for the tree. This is the triangle for the building. This tree must be a redwood or something because it is much taller than the building. So, but what we do need to find is we need to find the height of the tree. And where is the height of the tree? Well, that's over here on the line segment HG. Okay. So here's what we're going to do. We need to find a scale factor. Right? We're dealing with similar triangles, and scale factor is the name of the game. So I'm going to treat my building as my preimage and my tree as my image. So when I want to find my scale factor, image over preimage, I'm going to use the dimensions 18 and 16 because they're corresponding. So image is just 18 over 16. Let's simplify this a little bit. 18 over 16, that's 9 over 8. Okay. So now what I can do is I can use this number and I can multiply it by both of these in order to get, or the dimensions of my building in order to get the dimensions of my tree. So let's go ahead and do that. Let me test this first. What is 16 times 9 over 8? So let's see, and that equals 18. Yep, that works. All right, let's try it. So 40 over 1 times 9 over 8. Yes, I'm doing this without a calculator, and it is possible. So it looks like the height of our tree is 48 feet. And there we go. Okay, next problem that you will see on the test is some sort of transformation. This could be a reflection, it could be a rotation, it could be, I don't know if we'll do a dilation. It could be a dilation actually, okay? But this problem here is asking us to translate, okay? So we are going to slide, right? This is a slide transformation. We're going to slide point A here all the way over to point A prime over here, okay? And what I need you guys to do is I need you to measure this line segment. I think this is about 6 centimeters. I don't have a ruler with me, okay? But this is important information because we are going to translate points B and C the same direction, the same length. So what we're going to do is we're going to copy this line segment here. I'm going to paste it, okay? So there's now my translation for point B, okay? So point B, I'm going to switch colors here. Point B is going to be about right there. Actually, hold on a second. This line's a little bit crooked. I want to fix that. And be very precise with your lines, you guys, because these are geometric transformations. They need to be more or less perfect. And that's why you guys have tools. You have your rulers, you have your protractors, okay? So I expect straight lines and nothing less. All right. That's a little better. Okay. And let's erase this here. So this is also 6 centimeters. And at the end of this line segment here, I have my point B prime. Let's go ahead and do the same thing for point C. I'm going to paste another line segment. You're going to draw another line segment in the same exact direction. Okay. And let's erase this. This line segment that I just copied and pasted is also 6 centimeters long. And notice how they are parallel to one another. Each of these line segments that we drew are parallel to one another. And that's an important key here. Yeah, that was what we came up with for these rules of translations. the line segments you draw from each vertex to your whatever prime point, they must be the same length and they must be parallel. So now we have our new triangle, A prime, B prime, C prime. And there we go. All right, number 5. And actually, that's the last question we have on this study guide. Okay, number 5 says to describe how does triangle ABC, that's this triangle right here, move to triangle A prime, B prime, C prime, which is right over here. Okay, that dashed triangle, it's not solid. All right, rules for this. You must be specific as specific as possible. You must be specific, because if you just say translate, I'm not going to know where am I sliding this triangle. You have to tell me in what direction, how many units. If you tell me to rotate, where is my center of rotation and what is the angle of rotation? How far am I rotating this? Am I rotating it counterclockwise or clockwise? Okay, you have to be specific, and I can't emphasize this enough, because if you aren't, then I have to subtract points, and I don't want to do that. So let's take a look here. It looks like actually this A double prime, B double prime, and C double prime over here, this triangle, is a reflection of triangle ABC. So I actually might just say that I will reflect triangle ABC. You have to tell me, what am I reflecting? Don't just say reflect. Reflect triangle ABC, and I need my line of symmetry, or my line of reflection. What line is that? Well, that's over the y-axis. Okay, so now if I perform a reflection on ABC, I'm now at A prime, B prime, C prime. Okay. Now I need to take a look at this. How am I going to get, now that I'm going to change colors here. Now that I am here, how am I going to get to my final destination? Well, to me, it looks like I have another reflection here. Except this time I'm reflecting triangle A double prime, B double prime, C double prime over which axis? The x-axis. Okay. So again, be specific. I'm going to write a few notes down here. If you're going to tell me about a rotation, you have to tell me where is the center of rotation. So which point are you rotating around? You have to tell me that. What is the center of rotation? And then you have to tell me the angle of rotation. So for example, 90-degree rotation, right? I'll write that down, 90 degrees. And then in which direction? Clockwise, counterclockwise, okay? If you tell me just 90 degrees, I'm going to assume counterclockwise. But if you meant clockwise, you have to tell me so, okay? For reflections, I need you to list the shape, and I need you to tell me where is your line of reflection, where's your line of symmetry, okay? For a translation, for a slide, I need you to tell me which direction, right? And on a coordinate plane, we talked about up and down or left and right. Okay, so which direction, and then how many units? How many units? How many units am I moving to the right? How many units am I moving down or up or left? Okay? Be specific is the moral of this story. All right. Well, hopefully this helped, and I will see you guys in the next lesson.